Hello and welcome to lesson 6.3. Today we're going to look at similar figures. By definition, a similar figure is something that has the same shape but not necessarily the same size. So if you notice in the two pictures here, the side length here is 10 while this one is 15. So the sizes could be different. However, when I look at all my angles of my triangles here, notice how the corresponding angles are the same. Now, a corresponding angle is an angle that occupies the same relative position. So if you notice this angle up here and this angle up here, these are considered corresponding angles. Just like this side length here and this side length here, these are what we would call corresponding sides. Similar figures have two properties. Okay, first, the corresponding angles have equal measures, which we just saw, and the lengths of the corresponding sides are in proportion. So ultimately what that means is if we know a few angles and or sides, we can usually solve for other side lengths and or angles. So for example 1, it says parallelogram ABCD is similar to parallelogram EFGH. We want to find the value of x. So in order to solve this one, what you need to do is you need to use the image that has kind of like the complete set of data. So if you look at EF, and this is EFGH, I have two side lengths, while on ABCD, I have one side length and one variable side length. So what I'm going to do is I'm going to set this up as a proportion, okay? And I'm going to just start out by putting my variable on top. So I have x over 16 equals, now again, in that first proportion, it doesn't matter what you put on the top or the bottom, but the second one has to be in the same order. So because I put this side length right here on top, that means I have to put the corresponding side length, so in other words, that would be 18 on top of the other fraction. So then I end up with 18 divided by 24. Now we can go ahead and cross multiply. So I end up with 24x equals 288. And when I divide both sides by 24, I have x equals 12. And that would be then the side length from A to D. Now let's go ahead and do this similar type problem. We're going to say that EFGH is similar, so these two here are similar to KLMN. So again, if we know that, we're going to start out by setting up our ratio, and I'm going to start out with 18 on the top and 24 on the bottom. And then over here, notice the corresponding side length to side 18 is side length y. So my y will go on the top, and that means 21 goes on the bottom. And if I cross multiply these, I can see that I have 24y is equal to 21 times 18, which is 378. If I divide both sides by 24, I get y equals 15.75. In example 2, it says a building that is 70 foot high casts a 150-foot shadow. A nearby flagpole casts a 60-foot shadow. We want to draw a diagram and use similar triangles to find the height of the flagpole. So when you're dealing with story problems and proportions like this, it is recommended that you draw a sketch. Now I do have a sketch drawn here. Notice I have my building that's 70 feet tall with 150 feet shadow. I have my flagpole, and then I have the flagpole shadow, which is 60 feet. So what this does is this allows us to see which sides are corresponding. So now, when I go to set this up, I can go ahead and I'm just going to call this height of the flagpole h. So I have my variable h divided by 60, and I'm going to set that equal to the corresponding side lengths. So 70 and h are corresponding because these are the heights of my building or flagpoles, and then the shadow then is on the bottom, and I divide 70 by 150. So now when I solve this, I cross multiply, and I end up with 150h equals 4,200. I divide both sides by 150, and I'm left with h is equal to 28 feet. So that flagpole is 28 feet tall. For example 3, it says, a tree casts a shadow that is 10 foot long. A 5-foot woman casts a shadow that is 4 feet long. The triangle shown for the woman and her shadow is similar to the triangle shown for the tree and its shadow. How tall is the tree? Okay, so again, your very first step is going to be to draw a picture. So if I were to sketch this picture myself, here you have a person, okay, that is 5 feet tall, and they cast a shadow that is 4 feet long. And then you have a tree. Okay, we don't know the height of that, but that tree casts a shadow that is 10 foot long. So your pictures can be pretty simple, or I could have done something like my person. So this was 5 foot, this was 4 foot, and then my tree, which was h and 10 feet. You could have done something like this as well. I do happen to have a nice picture, so we'll use that, and we're going to use proportions to solve this. So the height of my tree is h, and I'm again going to set this up. So I'm going to put my h on the top, divided by 10. My corresponding side length to h is the lady's height, which is 5, and the corresponding shadow length would be 4. So again, we're going to cross multiply, and we have 4h equals 50, or h equals 12.5 feet tall. The next thing we're going to look at is something called a scale drawing. Okay, so a scale drawing is an enlarged or reduced drawing that is similar to an actual object or place. The ratio of a distance in the drawing to the corresponding actual distance is the scale. Okay, so an excellent example of this would be like a map. So here it tells us the scale of the map is 1 inch to 40 miles. So in other words, every inch that you measure on that map is 40 miles. So it says about how far from Atlanta is Athens. So notice we have Atlanta right here and Athens right here. Okay, so I'm going to start out with a scale that I'm given, and please keep your units with your numbers. So I have 1 inch for every 40 miles. And that's going to equal, so I can see here on the scale that that's about 1.5 inches, but I don't know what the distance is, so I'm just going to call that x. Okay, so again, I'm going to cross multiply, and I end up with x equals 40 times 1.5 is actually 60 miles. So the distance in between Atlanta and Athens is roughly 60 miles. For the second part, it says the distance from Atlanta to Macon is about 75 miles. What is the approximate map distance between the two cities? So here I don't actually have to measure. I'm going to start out with my 1 inch for every 40 miles equals. Now notice that they tell me that it is 75 miles. So my 75 is going to go down here. I have to find out what is the distance on the map. So again, if I cross multiply, I have 40x equals 75. If I divide both sides by 40, I have x equals 1.875 inches. For example 5, it says the scale of a map is 2 centimeters for every 15 kilometers. Oops, that's km. Okay, we have to find the actual distance for each map distance. So on the map, you measure 6 centimeters, but I don't know what the actual distance is. So if I cross multiply, I have 2x equals 90. If I divide both sides by 2, I end up with x equals 45. And that would be kilometers. For number 22, I'm going to still use that 2 centimeters for every 15 kilometers. Set that equal to my 2.1 centimeters divided by x. This gives me 2x equals 15 times 2.1, which is 31.5. If I divide both sides by 2, I end up with x equals 15.75 kilometers. For 23, again, I have 2 centimeters over 15 kilometers. This is going to equal 10 millimeters. Okay, notice because it's in millimeters, I am going to have to adjust this to centimeters. So 10 millimeters is actually 1 centimeter. So here I'm going to put my 1 centimeter on the top over x. When I cross multiply, I have 2x equals 15, or x equals 7.5 kilometers. And then for the final one, we have, again, our 2 centimeters over 15 kilometers. And that's going to be equal to our 17.4 centimeters over x. So cross multiply, I get 2x equals 15 times 17.4, and we get 261, and we're going to divide everything by 2, and I find out that the actual distance is really 130.5 kilometers. For our last example, it says a 2-inch length in the scale drawing at the left represents an actual length of 20 feet. What is the scale of the drawing? Okay, so for our scale, I'm going to go 37. Our scale is going to be scale over the actual. So if I go scale over actual distance, and I'm told that I have 2 inches for every 20 feet, this is going to reduce down to 1 inch is really 10 feet. So you could write that as 1/10, or you could put 1 to 10, something like that. For 38, it says, what are the actual dimensions of the bath? Well, if you look at the bath, it looks like I have 3/4 of an inch by 3/4 of an inch. So I'm going to, my scale then would be, I'm going to convert that over to a decimal, 0.75 inches over x, because I don't know what the scale is, or I don't know what the sidewall dimensions are, but I'm going to use the scale that I just found up above. So that's 1 inch for every 10 feet. And when I cross multiply, I end up with x equals 7.5 feet. So your dimensions then would be 7.5 feet by 7.5 feet. For number 39, 39 says to find the actual width of the doorways. Well, again, I'm going to use my 1 inch for every 10 feet, and I can see that my doorways here are 1/4 inch, or 0.25 inches over x. So again, when I cross multiply, I have x equals 10 times 0.25 is 2.5 feet. And then my last step is to find the actual area of the bedroom. So let me move this up here. To find the area of the bedroom, we're going to first need to find or do the conversions for the side lengths. So I'm going to use my 1 inch over 10 feet, and I'm going to set that equal to this right here, which is 1.5 inches over x. So when I solve this, I get x equals 15 feet. And then I'm going to do the same thing for the 2 inch side. So again, I have 1 inch over 10 feet, and that equals 2 inches over x. So I end up here with x equals 20 feet. So to find the area of the bedroom, and this would be with, assuming that the bathroom wasn't there. So I'm going to put A sub B for the bedroom. I'll put BD so we know it's bedroom. I'm going to go 15 times 20, and 15 times 20 is going to give me 300 square feet. But then I have to go and I have to find the area of the bathroom. So area of, I'm going to put BT for bathroom. Well, that's going to be 7.5 times 7.5, because I am going to have to subtract out that area of the bathroom. That's 56.25 square feet. And then now all I have to do is subtract these two numbers. So if I subtract these, I end up with an area that is equal to 243.75 square feet. Please let me know if you have any questions. Otherwise, I will see you guys in class. Have a great day.